I, in this video, I will be presenting about my machine learning coursework project. So in this assignment, I was required to build an image classification system using the neural network model. So I choose to implement a convolutional neural network to train on the CIFAR10 dataset, which contain 10 different category of every object. So in this presentation, I will walk through of my code step-by-step explanation with the key design decision, and I will demonstrate with the final performance of my project. So let's get started. So as we can see in here, so to begin with my project, I also imported for my required library like TensorFlow, Keras, provide for the code deep learning to pay for the to wave and train to the neural network. Also, NumPy is using for the numerical operation like the array manipulation, particularly for import data from within a meta methodology is used for the data visualization session like protein training curve and previewing simple image, and also this library together from the standard foundation cited for building CNN-based image classification model. So the next thing is I also loaded for the CIFAR10 dataset, which contains around 60,000 color image across the 10 classes, and the dataset is also already separated into the 50,000 uh, training image, then 10,000 training image. So after loading after I loaded that, I also normalize for the image parser value by dividing like 255 to, and also I also converted into the parser range from 0 to 1, and which is also important that because it can be how optimize our converge faster and prevent unstable gradient during the training, and normalization is also standard for the pre-processing step in nearly all modern neural network training pipeline. So after that, I before I training, I so in here I also display for one similar thing from each of the safe classes for both training and testing set. So I thought that can be held and verified that the data set was loaded correctly and that the classes are even distributed. And it also gave a visual confirmation that the image are relatively small in size, so which explain why convolution and network are a good architectural choice of these datasets. So after that, I also prefer the CNN model. So I also define for the CNN core model. The first three blocks consist of the convolutional layer, then that land low level and mid level visual patterns such as like edges, corner, and texture. So I also apply for the bench normalization uh, for band normalization after each convolution to stabilize activation and improve coverage speed. So also mass pooling is used for after first to overload to reduce the spatial dimension and make the neural network more computationally efficient. So I also add for dropout to each block to reduce the overfitting by randomly like this disabling during training. So after that, the convolution that is data I flatten to the output and to pass off the stack for fully connected this layer. These are hidden layer along to more to the model more abstracted and class specification representation. So each dance layer also have a best normalization and trouble to further stabilize training and improve generalization. So the output layer can be used for the software activation and which generate probability value for each of the say each of 10 like the CIFAR 10 classes. So after that, I compile the model using the Arden optimizer, so which also adapt the learning rates during the training and generally perform better standard than the gradient descended. The last function is that last function spiral categorical cross trophy, which is also suitable for the multiple classes class specification with the integer level. So I also included with the two important thing, training callback like the early stopping and the next thing is more chap y. So early stopping more show for the validation accuracy automatically stop training when the model stop improving and which prevent overfitting. So the next one, model checkpoint say for the best performing model wages so that even it is later echo of the decline in accuracy, that like the best present is still preset for it. So after that, after that training, I evaluate for my project or my model of the text dataset to measure for the generalization performance. So as we can see here, the model consistently achieve around like 75 to 85% accuracy, which is really strong for the manually designed CNN without transport laning. So I also test on the model on a single sample from the test to the verify that correctly classified as an image, and also that can be confirmed that the neural is successfully learn from the meaning feature. So to summarize for this project, like in this project, I can we can completely learning for the deep learning workflow and studying from the data preparation and the model architecture to design to the training and evaluation, the final interface testing, and also by incorporating branch normalization and dropout, early stopping, and model checkpoint. So in this way, we can improve both of model stability and generalization accuracy. So the final test accuracy is, as we can see in here, the final test accuracy is like 75 to 85%. It shows that the model is performing reliability without overfitting. So in this cohort, uh, I think this cohort giving me a predicate experience to building in the CNN for the scratch and applying model training optimization in the real image classification scenario. So maybe in the future I can extend this model by using the data augmentation or transparent learning for even higher accuracy. So in that conclusion, if I say it, like we can uh we can extend for this model by using the data augmentation or maybe in the transport learning for even higher accuracy. So thank you everyone for watching my video for my explanation for the coursework too. Thank you for everyone to pay attention on my video. Thank you.